Okay, next move to problem 4. Use division to obtain the Noether series of representation. Here 1 over e to the g negative 1 is equal to 1 over g negative half plus 1 over 12 times g, over the function disk given by this modulus g is greater than 0 and less than 2 times 2 pi. We need to exclude the singularity. In this case, e to the g negative 1 equal to 0 when, if and only if, I mean that g is equal to 2 and pi I. Here m is a natural number. So we can use another way, like this Euler formula. Then we get the same result. You can see the figure center of this slide. Then just apply the Macron series of e to the g. We know that where. Then we get this. 1 is cancelled because there is 1 also in the problem. So we get this. We need to compute the division. I mean that 1 over g plus g squared divided by 2 factorial, like this. Then we just do division on the right hand side here. Then we get this the exact result in the problem here. Okay, you can do it, I think. Okay, next move to problem 5. Note how the following expansion is an immediate consequence of the Noether series 8 in section 73. Here 1 over g squared hyperbolic sine g equal to 1 over g cubed plus g negative 1 over 6 times 1 over g plus 7 over 360 times g, something like that, over the functional disk given by this. Then use the method illustrated in example 4, section 6.8, to show that integral along to control c dg over g squared hyperbolic sine g is equal to negative pi I over 3 when c is the positively oriented unit circle. That is modulus g is equal to 1. Okay, first we find singularity for this function, which makes the denominator 0. In this case, g squared times hyperbolic sine g is equal to 0 if and only if g equals to 0 or g equals to n pi I. Here n is natural number. To compute this condition, this result, we use this identity equation. I mean that actually we know that by theorem in section 39. From this we get this result. So f of g has the Noether series expansion in the annulus given by this. So modulus g is greater than 0 and less than pi. It's a kind of functional disk here. We know where hyperbolic sine g can be expanded by using this Macron series expansion here. So we can use this to resolve the problem. In the Noether series expansion, f of g can be expressed by this summation n to the negative infinity to infinity cn times g to the n, where c sub n is 1 over 2 pi I times integral along to control c f of g dg divided by the n to the n plus 1. Here n is integer for the positively oriented unit circle C. Since this function can be replaced by this, because hyperbolic sine g is this, then just if we do division for this, then we get this result. Here, as I said just before, Cn is defined by 1 over 2 pi I integral along to control c f of g dg divided by g to the n plus 1. When we consider n is equal to negative 1, I mean that n is replaced by negative 1 here, negative 1 for n, negative 1 we insert here, then g to the power of 0, which means that 1. So this part would be integral along to control c f of g dg. Okay, 1 over 2 pi I times c negative 1. Then if we multiply 2 pi I both sides, we get this 2 pi I times c sub negative 1 integral along to control c f of g dg. Here, it's a problem to ask what is this value. Then, because c sub negative 1 is equal to negative 1 over 6, this 1 over negative 6, negative 1 over 6, then multiplied by 2 pi I, we get this negative pi I divided by 3, which is the result for this problem. A similar problem we have dealt with example 4. Okay, can you remember here?